The George Carruthers Story. On a clear night in 1949, a 10-year-old boy in Cincinnati, Ohio, peered through a telescope he had built himself from cardboard tubes and mail-order lenses. The money to buy those lenses came from his earnings as a delivery boy, saved penny by penny. That boy was George Robert Carruthers, and he was gazing at the same stars that would one day reveal their secrets through his revolutionary inventions. Born on October 1st, 1939, George was the eldest of 4 children in a family that valued education and curiosity. His father, George Carruthers Sr., was a civil engineer in the United States Army, and his mother worked for the U.S. Postal Service. The senior Carruthers played a significant role in nurturing his son's budding interest in science, encouraging the boy's fascination with astronomy and space. But tragedy struck early. When George was only 12 years old, his father died suddenly. His mother, facing the enormous challenge of raising 4 children alone, moved the family back to her hometown in the South. This loss could have derailed a young man's dreams, but George's passion for the stars only grew stronger. As a child who devoured science fiction novels, George found solace in the infinite possibilities of space. His early interest in astronomy was so profound that he built his first telescope when he was just 10 years old. This wasn't just a hobby, it was the beginning of a lifelong mission to unlock the mysteries of the universe. George's academic journey wasn't without its challenges. Although a brilliant man with multiple scientific accomplishments, his academic success was not immediate, but persistence and passion drove him forward. He pursued his education in physics and engineering, eventually earning his PhD and joining the U.S. Naval Research Laboratory, where his most groundbreaking work would begin. The 1960s were a time of unprecedented space exploration, and George Carruthers was at the forefront of innovation. In 1966, Carruthers built, and in 1969 received a patent for, an image converter that turned images made from light of very short wavelengths into electron images. This breakthrough was revolutionary. It enabled capturing an entire spectrum in a single exposure and was more robust than traditional ultraviolet films. But George's most famous invention was yet to come. He created the ultraviolet camera, or spectrograph, which was used by NASA in the 1972 Apollo 16 flight, revealing the mysteries of space and the Earth's atmosphere. This far ultraviolet electrographic camera used ultraviolet light to make significant advances in studying Earth's upper atmosphere, stars and gases in interstellar space. The significance of this moment cannot be overstated. Carruthers developed and built a compact and powerful ultraviolet electronographic telescope, which became the first and still the only astronomical instrument sent to the moon. It was placed on the lunar surface on Apollo 16 in 1972, and it performed extremely well. Think about that for a moment. A device created by a man who built his first telescope from cardboard as a boy was now sitting on the surface of the moon, 240,000 miles from Earth, capturing images of the universe that had never been seen before. The camera still stands on the moon today, a testament to George's engineering brilliance and humanity's quest for knowledge. The scientific impact of George's work extended far beyond that single mission. His work demonstrated that molecular hydrogen exists in the interstellar medium, a discovery that fundamentally changed our understanding of space. He gained international recognition for his work, which focuses on ultraviolet observations of the Earth's upper atmosphere and of astronomical phenomena. George Carruthers didn't just invent instruments, he opened new windows to the universe. His ultraviolet cameras allowed scientists to see what had been invisible before: the composition of distant stars, the behavior of Earth's upper atmosphere, and the very building blocks of space itself. This wasn't just scientific advancement, it was expanding the boundaries of human knowledge. The accolades and recognition that followed were well-deserved. For his contributions to science and engineering, he received many honors, including the Exceptional Achievement Scientific Award from NASA in 1972 and the Warner Prize in 1973. Carruthers was inducted into the National Inventors Hall of Fame in 2003, and in 2011, he was awarded the National Medal for Technology and Invention. He received the National Medal of Technology and Innovation, presented by President Barack Obama at a White House ceremony in 2013. But perhaps George's greatest legacy wasn't just his inventions. It was proving that curiosity, persistence, and vision could overcome any obstacle. From a fatherless boy building telescopes from cardboard to a world-renowned scientist with instruments on the moon, his story embodies the power of human ingenuity and determination. George Robert Carruthers died on December 26, 2020, in Washington, but his contributions to humanity's understanding of the universe continue to resonate. Every time we look up at the stars and wonder about our place in the cosmos, we're following in the footsteps of that 10-year-old boy who dared to build his own telescope and reach for the stars. Apollo 16 astronauts placed the observatory on the moon in April 1972, where it sits today on the moon's Descartes highland region in the shadow of the lunar module Orion. Asked to explain highlights of the instrument's findings for a general audience, Dr. Carruthers said, "The most immediately obvious and spectacular results were really for the Earth observations because this was the first time that the Earth had been photographed from a distance in ultraviolet UV light, so that you could see the full extent of the hydrogen atmosphere, the polar auroras, and what we call the tropical air glow belt." Dr. Carruthers made the first detection of molecular hydrogen in space in 1970 using a sounding rocket. He developed a rocket instrument that obtained a UV image of Comet Halley and an instrument with two cameras with different far UV wavelength sensitivities used on the STS-39 space shuttle mission in 1991. He also worked on UV imaging of Earth's polar auroras and of the faint photochemical luminescence found in the upper atmosphere with an instrument, Global Imaging Monitor of the Ionosphere, or GIMI, on a Department of Defense satellite, the Advanced Research and Global Observation Satellite, ARGOS, launched in 1999. In 2012, he was awarded the National Medal of Technology and Innovation, the nation's highest honor for technology achievement. Dr. Carruthers extended his work beyond his scientific endeavors. In the 1980s, he helped launch a program called the Science and Engineers Apprentice Program, which gives high school students the opportunity to do research at the Naval Research Laboratory. He also taught science classes at Howard University in Washington, D.C. Dr. Carruthers passed away on December 26, 2020, and is remembered for his contributions to physics, astronomy, and education.